Thank you for viewing this brief presentation on the Department of Transportation Airports Division, or DOTA's Environmental Construction Program. You have an important role in preventing pollution from construction activities on DOTA airports and protecting our state's receiving waters. The main goal of the DOTA Environmental Construction Program is to ensure that construction activities at the airport are planned and executed in a manner that prevents pollutants from discharging from the construction site. This will ultimately ensure that clean water is available for everyone to enjoy, including our neighbors, visitors to the islands, and the wildlife that lives in our state. Clean water is of vital importance to the local economy through the fishing industry and tourism. Ensuring that our waters are being protected has become the standard for doing business at the DOTA airports. All personnel involved in the construction process are expected to comply with the DOTA Environmental Construction Program. This includes the DOTA division and district engineers, as well as tenants who may initiate construction projects at the airport. Design consultants must be aware of the environmental requirements and incorporate the appropriate best management practices, or BMPs, into their design. Construction managers will ensure that BMPs are properly implemented at construction sites. Contractors will follow the BMP plans and ensure that their workers are trained in maintaining the site-specific BMPs. Another requirement of the DOTA construction program is that every individual working at the airport must be aware of the DOTA environmental policy as put out by the Director of Transportation. The policy includes the acronym COP, in which the C stands for Continual Improvement, the O stands for Obey All Laws, and the P stands for Prevent Pollution. The full policy is available on the DOTA website. Remember that the DOTA would like for everyone to be a COP. Stormwater runoff can carry pollutants from construction sites to adjacent storm drains or waterways. Once stormwater has entered the storm drain system, it is directed through pipes to the receiving water without any treatment. Therefore, it is vital to control potential sources of pollutants before they are impacted by stormwater runoff and possibly discharged to the storm drainage system. Sediment is a common pollutant from construction activities. Studies have shown that between 35 and 45 tons per acre per year of sediment can be discharged from an unstabilized construction site. By contrast, approximately 1 ton of sediment per acre per year is discharged from a stabilized or grassed area. The excess sediment and stormwater runoff becomes a concern because it can seriously affect the coral reef systems and other water creatures by blocking the transmission of light, blanketing the reefs, or clogging the gills of fish. This damage not only harms the environment, but can also affect the economy and lead to regulatory fines. Construction projects may have both short-term and long-term impacts on the environment. Specifically, construction sites usually result in the installation of increased impervious areas, such as paved parking lots, roads, and buildings. The more impervious areas there are, the less the stormwater can infiltrate into the ground. With decreased infiltration, there will be an increase in stormwater runoff and with it a higher potential for pollutants to be discharged into the storm drain system. Therefore, in order to mitigate this impact, the DOTA requires that construction projects also include permanent BMPs that will remain on site following construction to treat the stormwater runoff on a long-term basis. There are several specific environmental regulations that govern construction activities. The DOTA has detailed specific requirements for construction sites on airport property with the SWMPP Section C and D, which can be found online at the website shown. Additionally, the State of Hawaii Department of Health, or DOH, requires that National Pollutant Discharge Elimination System, or NPDES permits be acquired in several circumstances. These circumstances may include any land disturbance over 1 acre, when dewatering must occur on site, or during hydrotesting. Depending on the type of construction activity, there may be additional required permits. Specifically, if there must be a discharge or a new connection to the DOTA storm drain system, then a DOTA discharge permit must be obtained. Other permits may include the Army Corps of Engineers permits, the DOH 401 Water Quality Certification, County Special Management Use Area permits, and/or Federal Aviation Administration regulations. The DOTA defines construction as any activity that disturbs land, which includes the penetration, turning, moving of soil, or the resurfacing of pavement with exposure of the base course. This may include construction roads, staging areas, stockpiles, grading, grubbing, and demolition. If you are uncertain whether your activity meets the DOTA definition of construction, please assume that it does and submit your construction plans to the DOTA Environmental section for review. Their contact information is available at the end of this presentation. The DOTA categorizes construction projects by project management. Some projects are planned and financed by the Department of Transportation, and other projects are initiated by tenants on airport property. The type of project management will be used to identify how to best provide environmental oversight. Additionally, projects may further be grouped by size, since projects that disturb an area greater than 1 acre have increased requirements for permitting. However, it should be noted that the DOTA must provide oversight for all projects, even if they are less than 1 acre. The DOTA has evaluated some of the projects that occur at the airport and determined that the environmental impacts of certain types of projects are negligible and therefore may be exempted from the DOTA program. These projects must not impact the storm drain system in order to be considered exempted. These exempted projects include land disturbance on a single lot that is less than 1/4 of an acre, post or pole installation, utility repair work, and parking lot repairs. Other projects that must comply with the DOTA process for environmental oversight is described in the Stormwater Management Program Plan, or SWMP, Sections C and D, which can be found online. A link will be provided on the last slide of this presentation. The flowchart depicted here roughly describes what is included in SWMP Sections C and D. After coming up with an idea for construction, the first step in the process is to select best management practices, or BMPs, that will be implemented to control potential pollutants at the construction site. BMPs must be implemented at construction sites. BMPs can include practices or procedures such as cleaning up a spill or picking up trash. BMPs can also include devices that are used to control pollutants, such as berms around the storm drains and stockpiles, secondary containment for chemical storage, and dust fence. The discharge of sediment is a common concern at construction sites. Therefore, the DOTA has included BMPs in the Stormwater Management Program Plan, or SWMP, that can be found on the DOTA website that addresses both erosion and sedimentation. Erosion results from the displacement of soil particles due to the wind or water runoff. If erosion can be controlled on a construction site, then sedimentation, which is the movement and settling out of suspended soil particles off-site, will not be a concern. Sediment is not the only potential pollutant from construction activities. Other common pollutants may include leaking vehicle fluids or spills from fueling activities, lavatory waste from portable restrooms, wastewater and concrete waste, or storage of chemicals on site such as paints and solvents. Further, aggregate stockpiles often include fine materials that can be carried away in stormwater runoff. Another concern is the generation of wastes, which need to be properly contained while on site and then disposed of. When selecting BMPs, first begin with planning. Proper planning of a construction activity can often mitigate the pollutants that are generated. Project managers should consider the construction schedule, attempt to conduct ground disturbing activities during the dry season, or phase construction so that segments of the site may be stabilized prior to disturbing the next segment. Additionally, project managers should attempt to isolate potential pollutants by placing them indoors, covering, or otherwise containing them. Attempts should be made to control the pollutants at their source, since removing pollutants downstream is much more difficult. For the next step in this process, the designer should identify potential pollutants that may be generated at the site from start to finish. This may include looking at the proper management of demolition wastes, controlling erosion during ground disturbance, the management of concrete waste from pouring the foundation, proper cleaning of painting equipment, and the use of pesticides or herbicides on installed landscaping. Appendix A lists various BMPs that may be applied to the construction site. These have been divided into several categories, specifically erosion control, sediment control, tracking control, other potential pollutants, and waste management. These BMPs are included as a framework. However, designers and contractors may implement other BMPs not listed here with approval from the DOTA Environmental section. Every construction project on the airport must implement some type of BMP in order to control potential pollutants generated by the activity. These BMPs must be documented in a site plan that includes a site map. Note that BMPs may be updated at any time during the construction as long as the changes are noted in the plans and initialed by the contractor. The selected BMPs must be installed prior to any construction work on the site, including demolition. Once installed, the BMPs must be maintained throughout the course of the work until the soil has been stabilized. Also think about unique challenges that may be posed by your construction site and be creative. Overall, the DOTA wants to prevent pollutants from entering the state's receiving waters, and therefore the DOTA is open to any creative solutions that designers and contractors can devise. Also, designers and construction managers should consider installing BMPs in series similar to the electrical circuit shown, so that potential pollutants can encounter several controls before they leave the site. For example, sediment from a stockpile may be controlled by berms placed around the stockpile, sweeping at the end of the day, and also filters in the storm drain inlets. In this way, if one BMP were to fail, there would be other BMPs in place to prevent a discharge of that sediment. Designers should consider all aspects of a project and consider alternatives to certain applications, such as refraining from the use of herbicides or fertilizers during the installation or removal of landscaping. BMPs for the application of those chemicals are described in more detail in the SWMP Section E. In general, applicators should ensure that they are not spraying near a surface water body or on a steep slope. The forecast should be consulted to determine whether rain is expected that day. The wind speed should be checked in an effort to ensure that spray will only be applied where it is intended. Also of importance is a requirement that applicators keep a log of their usage of these chemicals and report it to the DOTA Environmental Unit at the end of the year. In addition to BMPs that should be applied during construction, the DOTA requires the installation of permanent or post-construction BMPs. Permanent BMPs are vital because they will continue to address any potential pollutants long after a project has been constructed. For example, if a construction project is for a parking lot, consider adding a green parking BMP such as porous pavers or a central grassy swale to provide filtration for runoff and paved areas. This will reduce the quantity of runoff and will also assist with reduced pollutant loads such as oil drips from parked vehicles. Exemptions to the requirement for permanent or post-construction BMPs include sites that are disturbing less than 1 contiguous acre of land, linear utilities, and projects that will not discharge to any water of the United States. All other projects must select permanent BMPs and include it in the project design. The selected BMPs should be documented in the design review checklist. Permanent BMPs are discussed in further detail within SWMP Section D. Various factors should be considered when selecting a permanent BMP, including watershed and hydraulic conditions, as well as potential pollutants that may be generated. The designer should select a candidate BMP and size it appropriately to handle the runoff from the site. Most importantly, a plan for continued maintenance must be drafted, and in the case of tenant projects, a continued maintenance plan must be signed by the tenant owner. A retrofit feasibility study was conducted for the Honolulu International Airport to evaluate completed areas of the airport and the potential to alter or insert a permanent BMP. The study includes a list of 10 hotspots to be addressed as soon as possible and 24 proposed retrofits that are ranked in order of priority. The study is available on the DOTA website. An example of hotspots included in the report are the 2 triturators at Gate 6 and Gate 34. The triturators are locations where aircraft laboratory waste may be disposed into the sanitary sewer. The current design allows for the discharge of wastes to flow from the triturator to nearby storm drains if a discharge is not properly aligned over the pit. These illegal discharges have been noted by the Department of Health and Environmental Protection Agency on previous environmental audits. Therefore, retrofit options have been proposed to contain the triturators with perimeter curbing with a trench drain at the driveway opening, which would connect back to the triturator unit. Therefore, any spills in this area would be contained. Other hotspots and retrofits that were identified in the retrofit feasibility study should be evaluated when there is a new project at the airport. DOTA engineers may notify the environmental unit of this evaluation via email. The DOTA has compiled a list of preferred permanent BMPs that should be implemented where possible for a project. The list is available on the DOTA website and focuses on 2 main goals. The first goal is to retain as much stormwater on a project site as possible. The second goal is to install a treatment system to remove pollutants from the stormwater that is discharged from a project site. Many of the treatment BMPs are available through several different manufacturers. The maintenance section should be consulted prior to product selection so that continuing maintenance requirements can be met with standard equipment. Bioswales meet the objective of both retaining stormwater on-site and providing treatment. A bioswale consists of a channel where stormwater from a site would be directed and permitted to infiltrate into the ground, thereby reducing the quantity of stormwater discharge. Additionally, vegetation in these channels can be effective at removing quantities of pollutants that may be present in the discharge. Bioswales are ideally placed along streets, runways, taxiways, and parking lots where a significant amount of water needs to be drained from a paved area and can also support the vegetation growth. Underground detention systems are designed to drain an impervious surface area and direct it to underground compartments where the water is permitted to infiltrate and recharge the groundwater. This BMP is beneficial to use at the airport because it does not occupy space that may be needed for operational activities and also does not promote habitat for wildlife, such as birds, which are a safety concern for aircraft. It is often a good idea to include a pre-treatment device with the underground detention system to remove trash and other large debris. Also, ensure that infiltration rates are examined in the potential construction areas to ensure that the BMP will be able to drain the expected runoff. Another BMP designed to retain stormwater on site is pervious pavement. This BMP is beneficial in areas where impervious pavement is normally installed, such as parking lots. Pervious pavement is designed to perform the same function that normal pavement does, but also allows the stormwater to infiltrate into the groundwater. Several hydrodynamic separators have been included in projects at Hawaii airports and are designed to treat stormwater runoff as it leaves the site. Specifically, as the discharge flows through the system, it allows for solids to settle out or float to the top and cleaner water to be discharged to the receiving water. These work well in areas where solid waste is expected, such as public areas, loading docks, gates, and landscaped areas. Oil water separators are another option for stormwater treatment and have been implemented at several state airports. In contrast to the hydrodynamic separators, oil water separators are geared particularly towards the removal of petroleum products. This is beneficial in areas of the airport where maintenance or fueling operations are expected to occur, such as the gates and hard stands. Storm drain inserts can either be temporary or permanent. Temporary storm drain inserts, like filter fabric or berms, are only in place during construction. However, there are several manufacturers that have developed permanent storm drain inserts that can be included in catch basins to remove debris from the stormwater runoff. Durability and maintenance concerns should be evaluated in detail prior to selecting this BMP. For the Honolulu International Airport, storm drains have been ranked based on the amount of debris that has been removed from the catch basin. The highest ranked drains were included in the Retrofit Feasibility study and should be evaluated for the inclusion of storm drain inserts. Once the appropriate temporary and permanent BMPs have been selected, designers should compile site plans and complete the required paperwork. The DOTA environmental section is required to review all construction projects at the airport, regardless of size. Therefore, two forms have been created for designers to complete that describe a project and the BMPs that will be implemented. For sites that are less than 1 acre, the form from SWMP Section C, Appendix F, should be completed. The form should include a site map with project location, storm drainage features, and BMPs. In addition, for tenant projects that will be discharging to the storm drainage system, a permit to discharge must be obtained. The form for that permit is available in SWMP Section C, Appendix E, and must be approved by the DOTA Environmental Section upon approval of plan review. For sites greater than 1 acre, the Design Review Checklist is located in SWMP Section C, Appendix C, and can also be found on the DOTA's website under Useful Documents. In addition to the checklist, the designer must also include site plans with both temporary and permanent BMPs, the project location, schedule, contacts, and applicable permits. These permits will include the NPDES coverage for construction activities from the Department of Health, the permit to discharge to the storm drainage system from DOTA for tenants, and any other applicable permits. Often during the time of plan review, the final permits may not have been issued. Therefore, the designers may submit the permit applications with their plan review paperwork. Contractors must have final permits available for review during the initial inspection. In addition to those previously discussed, other permits that may apply to construction sites include NPDES for dewatering or hydrotesting, Special Management Use Area permit from the county, or Army Corps of Engineers permits. Designers should evaluate which permits are needed and include those with plan review documentation that is submitted to the DOTA Environmental Unit. SWMP Section C was recently updated and is available on the DOTA's website. In particular, a clarification was added that the storm drain connection or discharge permit from the DOTA is only required for tenant improvement projects. Additionally, DOTA has required that storm drainage features be included on site maps. The storm drainage features at the Honolulu International Airport are available at the website listed, and other airports are available upon request from the environmental section. A major part of the DOTA environmental construction program is to ensure that projects are reviewed prior to their initiation. Project managers should note that prior to finalizing construction designs, the environmental unit should be consulted. This is most easily accomplished by extending an invitation to a pre-design meeting. This will allow the DOTA environmental unit to identify areas where temporary and permanent BMPs may be implemented while there is still time and resources to make any necessary changes. Once designers have compiled the appropriate paperwork, the DOTA engineers will route the plans through the environmental section for review. This process may be repeated if the reviewer has comments that must be addressed prior to approval. Common reasons that construction plans have not received approval include that all the necessary paperwork have not been included or that the described BMPs were not adequate for the activities to be conducted. Once approval has been provided, the DOTA project manager will provide the first NTP. The following slides provide additional information about what to expect from construction site inspections and potential enforcement actions that may result from environmental violations. A single construction site will have several different types of inspections. These are conducted to ensure that situations which may result in the discharge of pollutants are promptly identified and corrected prior to a release or a fine from a regulatory agency. These inspections are a beneficial tool to ensure compliance for both the contractor and the DOTA. Several different inspectors are involved in the program, including the contractor, the construction manager or CM, and a third-party inspector, such as the DOTA environmental section and their consultants. As an update to SWMP Section C, the responsibilities of these individuals have been more clearly defined. The contractor has the overall responsibility to ensure that their activities are not impacting the environment. In particular, this should be accomplished by installing BMPs according to their plan. This should be accomplished during the period of the first notice to proceed. Contractors are not allowed to proceed with any other work until an initial inspection has been conducted on the site. As work progresses, contractors may make updates or changes to their BMPs as needed to control potential pollutants. These changes should be noted in the BMP plan and initialed by the contractor. Inspectors will evaluate these changes during their periodic inspections. Once the second notice to proceed is issued, the contractor must do a daily walkthrough of the site's BMPs to ensure that they are implemented, maintained, and controlling site pollutants. Their observations must be logged and be available for review by third-party inspectors. Contractors must accompany third-party inspectors so that they can produce the necessary permits and documents for review, also so that they are aware of any deficiencies that need to be corrected. Contractors must also provide training to employees that are working on the site. These workers must be trained on site-specific BMPs, and those training records will be evaluated during inspections. Please note that regulatory agencies can ask any site workers questions regarding environmental compliance, and it is vital that at a minimum, employees should understand how their actions could impact the environment. Construction managers, or CMs, are retained to oversee DOTA projects. CMs also conduct inspections for BMPs to assist in ensuring compliance with environmental regulations. Weekly, a written CM inspection report should be submitted to the project manager and environmental unit. The inspection report format is available for download on the airport environmental website. Please note that as a recent revision to SWMP Section C, inspections are no longer required following a rain event. The contractor will be conducting a daily inspection to address any maintenance concerns that may arise from significant storms. Third-party inspectors will conduct the initial site inspections following the first notice to proceed, or NTP. Typically, the inspector will contact the project manager to determine when the contractor is ready for inspection. usually within 30 days of the first NTP. The project manager will issue the second NTP to start construction activities once any deficiencies identified by the third-party inspection have been corrected. Throughout the construction project, the third-party inspector will continue inspections. These inspections will be set on a monthly schedule unless the inspector determines that due to previous deficiencies, more frequent inspections should be conducted. The third-party inspector will also conduct a final inspection at the site to verify that all disturbed areas of soil are properly stabilized prior to the removal of temporary BMPs. The final inspection also serves as the initial inspection for any post-construction BMPs that may be installed on the site. All the inspections will be documented on the inspection form from SWMP Section C, Appendix D, and documented in the DOTA database. In addition to third-party inspectors, the project manager and contractors should be aware that regulators such as the Department of Health, or DOH, and the Environmental Protection Agency, or EPA, can conduct inspections of the site. Although inspections are usually scheduled with the project manager, CM, and contractor, inspectors such as the DOH and the EPA can choose to show up to a site unannounced. Typically for those sites outside of the secured areas, regulators will arrive unannounced. Therefore, it is important to be prepared at any time. Inspectors will report to the contractor's office when they arrive on site and will request to review all the applicable paperwork. This may include the latest update to the BMP plan, permits, employee training records, and contractor self-inspections. The BMP plan in particular will be used to evaluate the remainder of the construction site. Therefore, it is vital that this document is kept up to date. Overall, an inspector is looking to ensure that all the BMPs in the site plan have been implemented and are properly maintained. Then they will look at the place where pollutants may be discharged from the site, including storm drains and construction entrances, to determine whether they are properly controlled. The third-party inspection findings are always communicated verbally to the contractor at the end of the inspection so that corrections may be made immediately. Following the final conference, a written copy of the inspection findings on the inspection form will be provided via email. Contractors should respond back with photos of the corrections made or a plan for correction. The inspector will then set a time for re-inspection to ensure that the corrections are completed. Presented here is a list of the most common deficiencies identified during third-party inspections. The following slides will describe the associated problem and present solutions for correction. It is important for everyone to be aware of the site-specific BMPs and the associated requirements for continued maintenance. Many times, employees' knowledge of the right thing to do has made the difference in determining site compliance. During inspection, sites have either not had the BMP plan available on site or it was not updated. The plan is the basis for how a regulator will evaluate the site. Therefore, it is vital to have the plan available and up to date so that it is clear which BMPs should be present on the site. The construction site pictured here did not have a trailer on site in which to store the BMP plan. Instead, an installed plastic sleeve was used on the site so that it was available for workers and inspectors. Another common issue relates to the construction site entrance. The tracking of sediment onto the road is something that is easily visible to both inspectors and the public. Therefore, it is vital that construction entrances have sufficient BMPs to remove the sediment from vehicle tires prior to exiting onto the street. One way to prevent tracking is to install a stabilized construction entrance. Specific details for stabilized construction entrances are included in SWMP Section C, Appendix A. In general, the entrance should be a minimum of 50 by 30 feet and covered with 3 to 6 inch diameter aggregate. Maintenance may need to be conducted throughout the life of the project to remove accumulated sediment and keep the aggregate from settling. If tracking persists, additional BMPs can be implemented, such as regular street sweeping, washing vehicle tires as long as the wash water is properly contained, and stabilizing the source of the sediment. Silt fence can be used to control sediment throughout a construction site. However, it must be properly installed and maintained. When it is not maintained, sedimentation may be carried off-site and result in an illicit discharge. Silt fence should be properly installed and maintained by setting the post on the downstream side of the fence every 6 to 8 feet. The fabric should be stretched tight and the fence should be backfilled approximately 6 inches to secure the bottom of the fence. The goal of a silt fence is to hold the water back like a dam. There are other products, such as filter fabric, that will let the runoff pass through. However, the silt fence is designed to keep that water on site and any associated pollutants. To aid in achieving this goal, installation should include properly joining segments of silt fence. This can be accomplished either by twisting the two ends together or by overlapping them. Additionally, the ends of a silt fence should be placed in a J-hook pattern to prevent the stormwater from flowing around the fence. Filter fabric can be used to protect storm drain inlets from potential pollutants. This should be used as a last line of defense, after properly containing potential pollutants at the source. A common finding during inspections is that the inlet filter fabric has not been maintained. Contractors should be conducting frequent inspections to ensure that torn filter fabric is replaced and accumulated debris is removed. Stockpiles of aggregate material stored on the construction site must be properly contained. This practice should be implemented to prevent fine material from being carried away in the stormwater runoff. Additionally, stockpiles should not be positioned near waterways such as drainage swales, storm drains, streams, or the ocean. By leaving some distance between the stockpiles and the waterways, the contractor will have a better chance of catching stray material that may be washed away during rain events. There are several ways to contain aggregate material stored on site. The stockpile could be covered, vegetated, or surrounded by a BMP device. These devices may include berms, silt fence, jersey barriers, or even concrete masonry unit walls to effectively contain the stockpiled material. Spills and vehicle leaks are a common source of pollutants on a construction site. Vehicles and equipment must be inspected regularly and leaks cleaned as soon as possible. It is important to have a spill kit on site so that cleanup materials are readily available to respond to these incidents. Another reminder is that spills are not completely cleaned up until the absorbent is removed and properly disposed of. Another common deficiency noted during inspections relates to good housekeeping BMPs. Trash and debris throughout the site can be picked up by the stormwater and discharged to the receiving water. Make it a regular practice at your site to clean up debris at the end of the day. There are several other good housekeeping BMPs that can be commonly applied at the construction site. Frequent sweeping of paved areas aids in removing sediment and debris. Regularly maintaining BMPs is also important and could involve removing accumulated sediment or repairing broken berms. Solid waste containers should be covered to prevent stormwater from impacting the wastes, and waste should be removed from the site regularly. Contractors should be sure to separate waste that may be hazardous waste from the solid waste items and manage those appropriately. Improper disposal of paint waste and painting equipment cleanout can introduce pollutants to the stormwater. When painting, ensure that a tarp or another device is used to catch any drips that may occur during the painting operation. When storing paints, place them within secondary containment, such as a spill pallet. Secondary containment is required for liquid materials and wet cell batteries. When painting operations are complete, ensure that the equipment is cleaned properly. This will include scraping off the excess paint back into the paint can and washing the brush or other painting tools into a contained area such as a bucket. The bucket and remaining water-based paint can be allowed to dry, and the remaining debris should be disposed of as solid waste. Please note that if oil-based paint is utilized, it is considered a hazardous waste and therefore must be managed differently from water-based paint. The creation of concrete areas on a construction site often results in the need to wash out equipment involved in the laydown of the concrete material. The improper washout of this equipment can generate stormwater pollutants. The concrete residue is a fine material that can easily discharge into runoff, which can change the pH of the receiving water. It is important to ensure that all concrete washout is properly contained. This can be accomplished by designating a container on site and removing the debris once the water has evaporated. Additionally, a cover may need to be added to the washout when rain is forecasted to prevent the wastewater from overflowing the containment. There are many new types of BMPs that have been developed by manufacturers. The one pictured here is called a hard surface guard and may be nailed into the pavement to keep potential pollutants on site. It is effective at filtering sediment and oil from the discharge water and can be reused on various jobs. Implemented BMPs can occasionally cause a discharge of pollutants that was not anticipated. In the instance pictured, a tire wash area generated excess wastewater that could not be controlled by the berm that was in place. In this case, the wash area was moved and additional aggregate was placed to increase the infiltration and stop the discharge. It is important to evaluate all implemented BMPs to determine whether they are effective at controlling potential pollutants and make changes where necessary. Spill kits must be kept on site and properly stocked. Spill kits should include personal protective equipment, a plastic bag or other container for disposal, non-sparking tools such as a broom, and absorbent. The absorbent may be items such as berms, pads, or clay granules. When a spill or a leak does happen on the construction site, ensure that proper response measures are conducted. This includes stopping work and shutting down equipment. Then attempt to determine the source of the spill and alert others in the area to the hazards. Furthermore, the supervisor should be notified so that they can make the determination if the spill can be cleaned up with materials on site or if a spill response contractor may need to be retained. Note that it is the contractor's responsibility to either clean the spill or retain a spill response company. If it is in your ability to respond, obtain the necessary items from the spill kit. Attempt to stop the source of the spill and contain the exterior of the spill area. Then apply absorbent to remove all spilled material. It should only take 10 to 15 minutes for the absorbent to work. Responders may need to work the absorbent into the spill using brooms, and then sweep and dispose of the absorbent material properly. All spills on the construction site must be reported to the airport personnel for record-keeping purposes. The phone numbers for reporting spills at each airport have been listed on this slide. Depending on the severity of the spill, additional notifications may need to be made. If a petroleum spill occurs that is greater than 25 gallons, has not been cleaned up within 72 hours, or has entered a waterway, the agencies listed should be notified. Confirmation of these notifications should be provided to the airport as well. Once the project has been finished, there will be a final inspection for the site that includes an initial inspection of the installed permanent BMPs. The goal of the final inspection is to ensure that all disturbed soil has been stabilized and sources of potential pollutants have been removed. This may include actions such as growing vegetation or paving the area, removing fuel and other chemicals used during construction, removing dried concrete washout debris, and any other construction-related items. Note that temporary BMPs should still be present during this final inspection and may not be removed until all deficiencies have been resolved. Please note that projects occurring in certain sections of the movement area may not use vegetation as a means of final stabilization due to concerns over bird flight hazards with aircraft. The means of final stabilization should have been discussed during the plan review phase. The secondary goal of the final inspection is to ensure that designated post-construction BMPs have been installed. An operation and maintenance agreement should be provided that details the continued maintenance requirements for the permanent BMP. Throughout the construction process, enforcement actions may be implemented where necessary to correct deficiencies identified. When deficiencies have been identified and enforcement becomes necessary, an inspector will verbally communicate their findings to the contractor to allow the contractor to begin correcting the items immediately. Once the inspection report has been drafted, it will be sent to the contractor and the project manager. Additionally, the inspector will set a time period for reinspection of the site. If a violation continues after the reinspection, or an illicit discharge occurs, additional measures may be taken such as withholding payment for DOTA projects or issuing a stop work order for tenant projects. Another change to the SWMP is the enforcement process, which includes an escalating process that is outlined in the Inspection and Enforcement Manual. This may include the issuance of a notice of apparent violation, fines, and a referral of the case to the Department of Health. Once a regulatory agency, such as the DOH, begins enforcement, there may be specific costs associated with each violation and compounded by each day the violation had occurred. The cost schedule shown on this slide may apply in varying amounts depending on the situation. However, in any case, this is a cost that all parties working on behalf of airport construction projects can avoid by following the program described here and in the SWMP Section C and D. Other updates to the SWMP include a more descriptive training program. The training requirements are broken down into 3 different types. The first is the DOTA-provided training, which is accomplished through viewing this presentation and retaining a training roster. This training roster will need to be presented during inspections and is geared towards project managers, construction managers, contractor managers, third-party inspectors, and tenant owners. The second type of training is for contractor employees who will be working on the construction site. These employees must be familiar with the site-specific BMPs and spill response procedures. Training rosters must be presented to inspectors during site inspections as proof of their training on these topics. Inspectors must receive on-the-job instruction in addition to the DOTA-provided training. Inspectors will work under a qualified inspector until determined through a letter of certification that they may inspect a site independently. Appendix A of the SWMP Section C has been updated to reflect the changes that were documented in the City and County of Honolulu's BMP plan, as well as observations made during inspections. These BMPs may be referenced when designers and contractors are selecting BMPs for their projects. Appendix D has an updated construction inspection checklist that inspectors and construction managers should use when documenting site inspections. Additionally, the DOTA has provided a Word version of the checklist for inspectors to use. The notification form for sites less than 1 acre has also been updated to clarify the signatory responsibilities. The DOTA has instituted this environmental construction program as a part of the standard business practices at the airport and should be followed by all persons involved in construction. If you have further questions, please contact the environmental section at the numbers shown, and remember that DOTA would like for everyone to be an environmental cop, ensuring continual improvement at construction sites, obeying all environmental laws, and preventing pollution.